Alright, I hope you guys are having a great weekend, and I hope you enjoyed this little theme music to start off our video. We've got division with exponential expressions today. The good news is this is our final exponent properties video, where we're going to be simplifying some exponential expressions. So, with division with exponential expressions, there's two new properties we need to go over. I hope you enjoyed that music. Two new properties we need to go over, and we'll get to those in just a little bit. But to simplify an exponential expression, we must have a common base. A common base, meaning like a to the third times a to the seventh. Because both of these have the same base, a base of a, we're able to simplify these or combine these exponents. A to the third times a to the seventh, of course, is a to the 10. We have 10 total factors. But if we had something like m to the fifth multiplied by n to the sixth, because these are different bases, m and n being different values, we cannot combine these into one common term with only one exponent. We can rewrite it as m to the fifth times n to the sixth this way, but that's about it. And it's the same thing with division. If we were to have x to the fourth divided by y to the third, because these have different bases, an x and a y, there's really nothing we can do to simplify. However, if we had z to the sixth divided by z to the second, here we can simplify, and that's actually what this video is going to be all about. What does this simplify down to? And I think you guys probably have some good ideas on that already. Let's move down here to our quotient rule. This is our first new property of exponents that we're going to talk about today. And quotient rule says this: to divide two powers with the same base, that's what I was just talking about with those earlier examples, the same base, you just subtract the exponents. So with this I guess general form here, we have m to the c power divided by m to the power of d. So m to the c over m to the d. The way to simplify this is you take the denominator exponent and you subtract that from the numerator. So it becomes m to the power of c minus d. The top exponent subtracted from the bottom. Or sorry, the top exponent, and then you take away the bottom exponent. And that's actually how we can simplify. So another challenging example here, we have g to the third, h to the fifth, over g, h to the second. So the first thing you want to try to do is group which bases you can simplify. So from the very beginning, we have a g to the third, and we have a g in the bottom. So we have three factors of g in the top, one factor in the bottom. It's the same as saying g to the 3 minus 1. Then we have h to the fifth and h squared. So that's going to be multiplied by h to the 5 minus 2. And hopefully we can simplify this pretty quickly. It becomes g, 3 minus 1 is 2, so g squared times h to the third, or g squared h cubed, would be our final answer here. What happens though if maybe from the beginning we have larger powers in the denominator than we do in the numerator? So something like x to the fourth divided by x to the ninth. So now we have 4 powers up here and 9 down here. You can still rewrite this using our subtraction rule, or the quotient rule, and subtract the exponents. X to the 4 minus 9, and 4 minus 9, we get into some negative integers. It gives us x to the negative fifth. Now, hopefully from class on Friday and from the video on Thursday evening, you're comfortable with negative exponents. You know that we can't have a final answer with a negative exponent, so we must rewrite this as x to the x to the negative fifth is 1 divided by x to the fifth. 1 divided by x to the fifth. Just want to make sure you're paying attention. So that would be my final answer for this second example here. All right, we're going to move on down. Another way, instead of looking at the quotient rule to subtract, another way of looking at this is canceling out factors and common factors that we have in the numerator and denominator. For example, we're doing this same example that we had g to the third, h to the fifth over gh squared, but you can rewrite that. G to the third is g times g in my numerator, and h to the fifth, well, that's 5 factors of h. 4, 5. That's really the expanded form of my numerator. In the denominator, I have 1 factor of g, and I have 2 factors of h. So now it's kind of like a battle, or you can cancel out the common ones. We have 3 factors of g here, we have 1 down here. So one of these factors cancels with one of these factors. 2 of our factors of h cancel with the 2 factors of h down here. We're left with 2 factors of g and 3 factors of h, all in my numerator. So again, we get to g squared h to the third, just showing us another way of looking at these types of problems. So similarly here, if we have 7 factors of k and 5 factors of k in the denominator, where do we have more? In the numerator. And by how many? We have 2 more in the numerator. So we're going to be left with k squared. Moving on to the m to the third and m to the 10th, we have more in the denominator, and we have how many more? Exactly 7 more. So there's 7 factors of m that would be left in the denominator. All of the ones here would cancel. And then p, we have 1 factor of p in the numerator, 1 factor of p in the denominator. That actually cancels each other out, and we don't have any factors of p in our fully simplified answer. Okay, moving on. The next property, and it's really our last property with exponents, it's called power of a quotient. Power of a quotient. It's similar to power of a product. And it tells us this: to find the power of a quotient, you must find the power of the numerator and the power of the denominator. Another way of thinking about that is everything inside the parentheses, whether it's in the numerator or denominator, is being raised to the exponent that's on the outside. So to simplify a over b to the mth, it's a to the m over b to the m. Now, my next question is, can we take this any further? Hopefully you understand that that can't be simplified because we have different bases. We have an a here and a b here, and they have to have the same base to simplify. Another example here is 3x over 4y to the 5th all squared. So let me grab this here and slide it on over, because I'm going to do a couple examples. One way of looking at this is, again, just knowing that everything in the numerator needs to be squared, and then everything in the denominator needs to be squared. So it becomes 3 squared x squared for my numerator all over 4 squared. And then this y to the 5th is also squared. If you remember, it's taking a power and raising it to a power, and that becomes actually y to the 10th. You multiply the exponents still. And then we can simplify this to 9x squared over 16y to the 10th, and that'd be a final answer. Now, another way of doing this is just remembering that we're squaring a fraction. So it's 3x over 4y to the 5th times itself, times that 3x over 4y to the 5th. And then you multiply our numerators to get 9x squared, multiply the denominators to get 16y to the 10th. So again, a couple of different ways. This next little paragraph is what we looked at yesterday with the video, and I just wanted to put it up here one more time because I think it really helps describe how to simplify an expression and how to check that you've simplified an expression. So you can copy that down in your notes again if you didn't get it on the video from Thursday night, but you don't need to do it again if you did get it on Thursday night. I've got 2 final examples that I want you to look at and try to work out on your own. So go ahead and pause the video now and try to do these on your own. If you're having some issues, you can always push play and see how I work them out. All right, hopefully you were able to come up with these. If not, let's work them out together. With this first one, everything is being squared, so I'm going to take care of that first. It becomes 3 squared, n squared in the numerator, and then p becomes raised to the 6th because we multiply the powers. All over 7 squared, we got to square the 7, and q squared to the 2nd power becomes q to the 4th. So this is actually an acceptable answer, but we can square some of these and simplify it a little bit down. So it becomes 9 n to the 2nd, p to the 6th over 49 q to the 4th. And our last example right here, what I like to do first is take care of my negative exponents. We have m to the negative 4th. One way of looking at that is that this m is not happy with the location it's in. Okay, the negative exponent tells us that it wants to be in a different location with our fraction. So the m to the negative 4th can get moved down to the denominator, and then if we look down in our denominator, p to the negative 9th can get moved up to the numerator. So we still have 12 in the numerator, and we still have the p squared. Then we're going to move up this p to the negative 9th. It becomes p to the 9th because it's the reciprocal all over this negative 15 negative 15. We have the m to the third still down here, and we move this m to the negative fourth down, and it becomes m to the fourth. Now moving forward, 12 over 15, we can simplify that. That's the same thing as 4 over 5, 4/5. And it's a negative 5 because it was negative here. And then we can get our like terms together, as you can call them like terms, I guess, p squared and p to the 9th. That's a total of 11 powers of p. M to the third and m to the fourth gives us m to the 7th. And that would be my final answer here. All right, one last thing that we're going to look at for the weekend is a challenge problem. And I want you to try to take a look at this, work it out in your notes, and bring it in on Monday ready to present to the class if you feel like you did a good job with this. It's the quantity of 16x squared y to the negative first, all to the 0 power, all over the quantity of 4x to the 0, y to the negative fourth, z, all raised to the negative second. That's a pretty tough one here, with some negative exponents and 0 exponents. Let's not forget that property. Hope you guys are having a great weekend, and I look forward to seeing you on Monday.